Hello and welcome on board with me. My name Mambuna Bojang, and today I will take you through the three data structures called stacks, queues, and linked list. So, first of all, what do all these three have in common? Stacks, queues, and linked list. A stack, a queue, and a linked list are all data structures that help in storing a group of values. But how do they do this, and how exactly do we operate stacks, queues, and linked lists? This I will take you through right now. So we first begin with the stack data structure. So what exactly is unique of the stack data structure? The stack data structure is a data structure that stores elements with the principle of LIFO. What exactly do we mean by LIFO? LIFO is an abbreviation that means last in, first out. What sense does this make? Last in, first out simply means when you store elements in a stack data structure, the last element that you put will be the first element that you remove. When you want to remove or you want to access the elements, the last element is actually going to be the first element to access. That's what it simply means, last in first out. As in the picture, as in the presentation, a stack data structure simply talks about a stack data structure simply, you can think of a pile of plates whereby you just you just put plates on top of each other in a kitchen, and when you want to remove them or when you want to access the plates, you actually access the plate on top, and that plate is the plate you put last. This is what simply is a stack data structure. So if you look at the LIFO principle of stack, this is what it exactly is. As you can see, we added an element 1, 2, 3, but because 3 is the last number you put when you are removing elements, 3 is going to be the first number you remove. So stack is used in very many programming languages, almost all of them, like C++, Java, Python, and the list continues. Basic operations in stack. Push. Push and pop are the most important operations in stack. The push operation simply means adding an element to the stack, and the pop operation simply means removing an element from the stack. Is empty is to check whether the stack is empty, and is full checks whether the stack is full. So and it has a top pointer that helps you work with it in Python, and its complexity is O. The big O notation is just one. Application, you can use stack data structures in browsers. If you want to go back to the last website or the last tab you have been in any browser, you press the back button. That back button has been created with the help of stack data structures, which works in last in, first out. It's going to access the last place you have been going to. Yeah, so that's simply what a stack data structure is, and that's basically it. And it can also be used in reversing a group of elements. I am sorry if I didn't say that. In a group of elements, if you want to reverse, like a word, you have a word, a long word that you want to spell the word in in a reverse order, you can put all the words in a stack data structure and pop all of them out. When you pop them out, it will be spelled in a completely backward direction because the last element, it will write it first, and the trend goes like that. Thank you, and we go to the Q data structure. The second data structure we have is the queue data structure. What is the function of this data structure? The queue data structure works with the principle of FIFO. What do we mean by FIFO? FIFO is an abbreviation simply meaning first in, first out, meaning the first element you put in a queue data structure is the first element you are going to see when you try to remove elements. Think of it as a cinema, a ticket queue in a cinema, whereby the first person that comes to get the ticket is going to be the first person in the queue is going to be the first person to get the cinema tickets. That's exactly how a queue data structure works. As you can see, it's like a two-way open. When you put in the other one, the the way in which you put them is going to be the way in which you put them out. That's basically what we mean by a queue data structure. And there are basic operations in queue data structures as well. One of them is enqueue. When you want to add an element to the queue, you enqueue, and when you want to remove an element from the queue, you use the operation dequeue. And just like in stacks, when you want to check if it is empty, you use the operation is empty, and when you want to check if it is full, you check the operation is full. So now a queue has what we call a front and a rear. What is a front and what is a rear? A front tracks the first element of the queue, and the rear also tracks the last element of the queue. Initially, these values are set to -1 to ease how it is done. Yeah, so never forget that. Like here, the front is always the first element, and the n is always the last element of the queue. Yeah, so here is an example in Python as to how you can do a queue. You can work on a queue data structure, and it has so many importances. What are those importances? The importances of a queue data structure, the most important of them, which is not listed here, is actually in a printer. In a printer, the printer works with like a queue data structure, whereby if you put a list of things you want it to print, list of documents you want it to print, the first document you put in a printer is going to be the first document printed, and the second document is going to be the second, and the last will be the last printed, meaning first in, first out, uh, just like in queues. And queues used in computers can be used in CPU scheduling. And when data is transferred asynchronously between two processes, the queue is used for synchronization and handling of interrupts in real-time systems. Call centers, phone systems also use queues to hold people calling them in order. I hope that is clear enough. It also has a complexity which is called the big O notation. Um, we will get to explain that later perhaps. And limitations of the queue, it also has limitations like you cannot actually sort them just like in linked list, which we will actually talk about later. And when you pop or push an item, you cannot actually arrange them in order. So this is basically about it in queues, and see you. Now we go to the last one of the three, which is the linked list data structure. What is a linked list data structure? A linked list is a linear data structure, just like stacks and queues that store data, just like stacks and queues, but in a series of connected nodes. That is what differentiates linked list and queues and stacks. It stores data in a series of connected nodes. What do we mean by connected nodes? The nodes are actually connected, means each data in store is stored in its own repository with its address. And the first element of a linked list data structure is called a head, and the last element is called a null, whereby each element contains the address of the next one called next. So, um, linked list. If you want to understand structure of a linked list, all you have to do is try to practice it in Python. And what we use is called a struct node. A struct node will be the one that will help you in working with linked list. Representation of a linked list, as you can see in this Python code, we try to represent a linked list, and it becomes quite successful. It works with pointers and structs where we allocate memory and of a 1, 2, 3 memory first of all, and then when we allocate their addresses, now we allocate the values for the addresses. Remember, the first is always called the head, and the last is always called the null. And this is all about representation of a linked list, and an example or the benefit of a linked list. Linked list can be used in an undo option, in undo options in Microsoft Word or whatever you're doing. If you want to undo them, you can do linked list. And the biggest advantage it has is that it can actually break chains and rejoin them. If you want to remove the middle value, you can do it. If you want to remove the first value, you can do it. If you want to remove the last value, you can do it. Or if you want to add an element to the first value or want to add an element to the last value, you can do whatever you want. That is what makes linked list very special. For stacks and queues, you can only add to the last element or the first element. But here you can do add elements or remove elements from any point you want. Yeah. So like you can see here, it works in not just in Python but in Java, C++, and even the C data structures as well. So as you can see, it can use undo options. It can even be implemented in stacks and queues, and it has a dynamic memory allocation. And the operations it has is transversal, insertion, deletion, search, and sort. Like what queues cannot do, this guy can actually linked list can actually sort values in a way, arrange them in an ascending or descending order. Things to remember about queues. Yeah, if you want to transversing a linked list simply means to access all the elements in a linked list. Insertion means adding a new element, and deletion means removing a new element from the linked list. And here are a few examples to do that. Like I said, you can insert at the end, you can insert from the beginning, and you can even insert at the middle. Same for deleting, you can delete from the beginning, delete from the end, and also delete from the middle. You can do as much as you want. In linked list it is quite flexible, and as much as possible you can search for elements as well as sort elements. And here is an example of a linked list in Python. Thank you very much, and see you in the next video.